Hello, my name is Mr. Asprey, and this is my Edexcel IGCSE exam series 2. This is number 49, Surds. Let's do it! So, before we start, we must know that when we multiply the square root of a by the square root of b, it gives us the square root of a multiplied by b, like that. Other things to note as well is that the square root of a times by the square root of a is equal to just a. And also that the square root of a over the square root of b is just equal to the square root of a over b. So those are some classic surd laws. Okay, so let's start by multiplying out these brackets like so. So just like a simple set of brackets, we'll do this times this and this times this to start, which is 40, and it is plus 8 lots of root x. And then we'll do minus root x times by 5, which is minus 5 lots of root x. And then we'll do minus root x times by root x, which is just minus x, because like we said, the square root of the same thing times by itself is just whatever that thing is. Okay, so we can collect here because we have 8 root x's and minus 5 root x's, which makes a total of 3 root x's. And then we've also got minus x here as well. Okay, so we have been told that that is the same as this. So the left hand side, which we've expanded out, is the same as y root x plus 21. So what we're going to do is we're going to match up irrationals and rationals. So we're going to match up surds and non-surds basically. So on the left hand side we have 3 lots of root x. Now that is a surd. And then we also have, I'll put in brackets, 40 minus x, which is a non-surd, that's a rational number. And then on this side we've got this and we've got this. So once again, this is the surd part, which should match with the surd part on this side. And this is the non-surd part, which should match with the non-surd part on that side. And we can just compare now. So hopefully it's easy to see that 3 must be y. So y must equal 3. And that's just looking at the yellow part. We can get that from the yellow part. And from the green part, we've got that 40 minus x is equal to 21. So therefore x must be 19. And that comes from the green part. Okay, perfect. Okay, next question. And it says express these two added together in the form of k root 6. Okay, so first off, root 48 is the same as, now most of the time when we simplify surds we look for the highest square factor. So in this case that would be 16 because 48 is divisible by 16 3 times. Okay, so we could do that, and we could and then this is the same as, because root 16 is a square factor, so therefore the square root of 16 is 4. So we get this. We could do something similar to 108, which has a factor of 36. Yeah. So it's the square root of 36 times the square root of 3, because 3 36's make 108. Perfect. So that gives me 6 root 3, because the square root of 36 is 6. Then we're adding these two things together. So this is going to give me 10 lots of root 3. Now, that is not in terms of root 6, unfortunately. So we're going to have to rejig this slightly. So 10 is the same as the square root of 100, like so. Now 10 is also the square root of 50 multiplied by the square root of 2. Now, why have I done that? Well, I really want this root 3 to be a root 6, so I'm going to have to times it by a root 2. So I've taken out a root 2 from that 10, and now if I times the root 2 and the root 3 together, it gives me root 6. So it's going to be root 50 root 6. And that is the form that they want it in, because it says that k is a surd. So we're good. That's it. That's the final answer. It's root 50, root 6. Perfect. Okay, question 13. These are tricky questions. You have to have a good understanding of surds to see what's happening here. So we've got A, we've got B, and it's asking us to work out A minus B, which would be root 8 plus 4, minus all of root 8 minus 4. So that's the first part. That's A minus B, because we've got A here and we're taking away, and this is B. And I have to put it in brackets just to make sure that we apply the negative to the whole of B. And then we're going to multiply that by A plus B, which we don't need to use brackets for because we're adding. So we get this. Okay, so let's see what we have in total then. So reading along from the left, we're going to have a root 8 minus a root 8, so they're going to cancel. But we will get a 4 minus a minus 4, so that will be 8. So it'll be 8 out of the first bracket. The second bracket, we're going to get 2 lots of root 8. So we've got root 8 plus root 8. And then we're going to have the 4 minus the 4, which is just 0. Okay, so it is essentially 16 root 8. And now we have to write it in the form y square root of 4y. Wowza. Okay. So the first thing to note is that if we have y square root 4y, that's the same as y square root of 4 times square root of y, like that, which is the same as, well, the square root of 4 is 2, so it's 2 times y times the square root of y, we could say it like that. So ideally I want to have a factor of 2 outside. So let's rewrite this, what we have, as 2 lots of 16 is 2 times 8 times by root 8. Okay, so that's good. That looks pretty exactly what we're looking for here, doesn't it? 2 lots of something times by the root of that something. So it therefore goes to show that y must be 8. And we're done. Okay, next question, and looks like another one where we're going to have to multiply out the brackets. So the first one we're going to get 12, and then we're going to get 3 lots of root A, and then we're going to get 4 lots of root A, and then finally we're going to get just A. Perfect. And we're told that's equal to 17 plus k lots of A. Okay, so this is another instance where we have to equate coefficients. We've got to equate the irrationals and the irrationals. The rationals and the irrationals. The surds and the non-surds. So let's look at the non-surds. We've got 12 plus A. And the surds, we've got 7 root A. Okay, so once again, I can't remember what colours I used last time. I think we said that the greens were the non-surds, and the yellows were the surds. So just looking only at the greens, I think it's pretty clear to see that if 12 plus A equals 17, then a must equal 5. And then looking at the yellows, really clear to see k is 7. Bosh. Okay, so we've got a little indice question just out of the blue. I'm not sure why this is in here, but why not? P must be minus 3 because it's the reciprocal of 5 cubed. So the negative power makes the reciprocal. Anything to the power of 0 is 1. And if you cube and then you square root, that's the same as raising it to the power of 3 and also to the power of a half. So cubing and then square rooting would be to the power of 3 over 2. Okay, right, now we're on to some surds. It says show that this is equal to this. Okay, I'm going to try not to use my calculator here, for good practice. 14, 245, I think, is the square root of 5 and the square root of 49. Yes, because 49 times 5 makes 245, perfect. Which is the same as 7 is the square root of 49, so 7 times root 5. And then we've got 14 divided by 7 here, which is just 2 on top, because the 14 and the 7 cancel out to make 2. And then, to rationalise the denominator, we multiply the top and the bottom by the surd on the bottom, like so. So this gives us 2 root 5 on top, and it gives us root 5 times root 5, which is 5 on the bottom. Lovely. Okay, and we've got another question where we need to expand out and then equate the surds and the non-surds. So e minus 2 root 3 needs to be multiplied by itself, like so. This is going to give us e squared. It's going to give us minus 2e root 3. And we're also going to get another minus 2e root 3. And then finally, the last bracket is 2 negatives make a positive. 2 times 2 is 4, and root 3 times root 3 is 3. So we've got 4 times 3, which is 12. Perfect. And we're told that this is the same as f minus 20 root 3. So I'm going to write the non-surds like here. And then the surds will be minus 4e root 3 because there's 2 lots of 2. And that's equal to f minus 20 root 3. Okay, let's get our colours out again. The non-surds look like this, and the surds look like this. So from the green, there's 2 unknowns, e and f, so I'll start with the yellows. And again, I think it's relatively easy to spot here that e must equal 5. Because, well, yeah, divide, we've got minus 4 lots of e root 3 equals minus 20 root 3. We could divide through by root 3. We could divide through by a minus. And we could divide through by 4, which leaves 5 left over. So e is equal to 5. If e is equal to 5, then the greens become 25 plus 12 is 37. It's just equal to f. So there we have it. F is 37 and e is 5. Beautiful. Okay, it says that we've got k as an integer and m is a prime number. So that means we can't simplify the surd if it's a prime, because it's definitely not a square if it's a prime. So we have 8m plus 8 root m, sorry, and then we can split this one up into root 49 times root m, and we can split this one up into root 9 root m, and that's equal to k root m. So this is 8 root m, and this will be 7 root m, and this will be 3 root m. So overall, how many root m's have we got? We've got 8 plus 7 is 15, minus 3 is 12. So it's 12 root m is equal to k root m. Divide through by the root m's, we get k is equal to 12. 1 mark, bit stingy. Okay, now we're going to need to write this in this form. Okay, so the first thing I'm going to do is root 18 is the same as the square root of 9 times the square root of 2, which is 3 root 2. So I'm going to rewrite it like that, just because my final answer is in terms of root 2, so why not convert straight away? And this has been divided by this. Now, if we want to rationalize the denominator, then we need to multiply by that denominator, but with the sign in the middle changed. That is, if we have a surd and a non-surd on the denominator, like we have here. Okay, so we've got to do essentially a double bracket expansion on the top and one on the bottom as well. So without it getting too messy, that's going to be 5, and that's going to be plus 5 root 2. This one down here is going to be minus 3 root 2, and then this final one here is minus 3 times root 2 times root 2 is 2, so it's minus 3 times 2, which is minus 6. Okay, lovely. And then let's look at the bottom. So for the bottom, you can take a shortcut, which is to just do this times this and this times this. It's a bit cheeky, but it does save a bit of time. So it's 1, and then root 2 times root 2 is 2, but there's one negative there, so it's minus 2. And the reason why you could do that is because these other terms here will cancel. This one and this one. One gives you plus root 2. To be fair, show you're working clearly, you probably should do this. So you get plus root 2 and you get minus root 2, which will cancel out. Okay, so let's collect the things at the top. We've got minus 1, because we've got 5 minus 6, and we've got plus 2 root 2. And that's all over, again, these will cancel with each other, so it's just minus 1. Okay, so we can divide the numerator by minus 1 to cancel the denominator. So this gives me a positive 1 and it gives me a negative 2 root 2. Let's just divide, or multiplying the top and the bottom by a negative is going to give us this, all over 1, but of course we don't need to write that. So we get it in the form that we want. Perfect. Okay, we're rationalising the denominator now. So 4 over 7 minus root 5, and once again this is a denominator which has a surd and a non-surd in it. So we just write it out again, but we just flip the sign in the middle. Perfect. Okay, so multiplying the top, 4 times 7, 28. 4 times root 5, 4 root 5. The bottom, 49, plus 7 root 5, minus 7 root 5, and then the final one would be minus 5 times root 5, which is just minus 5. Sorry, minus root 5 times root 5 is minus 5. Yes. Okay, so on top, we can't simplify that yet. On the bottom, these will cancel with one another. So we're left with 49 minus 5, which is 44. And then we can take out a factor of 4 to get 7 plus root 5 over 11. And then this was a funny question, wasn't it? Because it actually asks you to give it in this particular form with a and b fractions. So we can say this is 7 over 11 for a plus root 5 over 11 for b. Just splitting up that fraction, writing it as two separate rather than one single, which doesn't seem like, it's not as nice, but whatever, that's what they asked for. Okay, let's go again. This time we've got 8 over root 5 minus 1. So once again that's a surd and a non-surd, so we just rewrite it. We multiply top and bottom by writing it out again, but changing the sign, like so. Okay, so multiplying out gives us 8 root 5 and plus 8 on the top. On the bottom we get root 5 times root 5, which is 5. We get root 5 times 1, which is just root 5. We get minus root 5, and then finally we get minus 1 times 1, which is just minus 1. Lovely. So simplifying, that's 8 root 5 plus 8 on top. These two in the middle cancel, so it's just 5 minus 1, which is 4. And we can divide everything through by 4 to get 2 root 5 plus 2 all over 1, which we don't need to write. So we're good. We're not quite good though, because again we've got to be really careful with what they've actually asked us for. And it just says root A. So at the moment that is in its simplest form. They don't want it in its simplest form. They want it as just a single surd, if you will. So 2 is the same as root 4. So we can write it like this, and then 2 surds times together like that, we can just combine them, and 4 times 5 is 20. So this is our final answer. Okay, next question, and I'm going to start off by taking this root 12 and writing it as root 4 root 3. Because 4 times 3 is 12, and root 4 is 2, so it's 2 root 3. So I've got 2 root 3 on top, and on the bottom I've got root 3 plus 2. And once again, because we've got a surd and a non-surd on the bottom, we have to write them out again, but just swap the sign in the middle and multiply top and bottom by that. So what do we get here? Well, root 3 times root 3 is 3. But we're timesing that by 2 as well, so it's 2 times 3 is 6. 2 times 2 is 4, so that's minus 4 root 3. On the bottom, we've got 3 times 3 is 9, so it's root 9, which is the same as 3. Here we've got minus 2 root 3. Here we've got plus 2 root 3. And here we've got minus 4. Okay, perfect. So this is 6 plus root 3 over, these will cancel, and we've got 3 minus 4 is minus 1. So dividing through by minus 1 just flips the sign of everything. So this becomes minus 6 plus 4 root 3. And then we've got the same thing as a similar question, the last question I believe. We've got root b, it wants it just as an unsimplified surd. So this is the same as, 4 is root 16, like so. So this is minus 6 plus, times those two together gives us 48, so root 48. Bosh. Okay, next question. Once again, we're rationalising such a common question. So it's 6 minus 3 root 2. So we're going to multiply top and bottom by 6 plus 3 root 2. So 6 plus 3 root 2. Okay, so what's this going to give us? So that's 12 plus 2 times 3 is 6, so it's 6 root 2. On the bottom, 36 plus 18 root 2 minus 18 root 2, and finally this last one, 3 times 3 is 9, root 2 times root 2 is 2, 9 times 2 is 18, so it's minus 18. Okay, so let's simplify the bottom to get those cancelling out. 36 minus 18 is 18. Cool, we can divide through by 6, so all terms can be divisible by 6, so it becomes 2 plus just a root 2 over 3. And that looks pretty good to me, because they're all integers. Perfect. Okay, this is an absolute monster video. Root 12 is the same as root 4 root 3, which is 2 root 3. So we can say 2 root 3 minus 1 over 2 minus root 3 needs to be rationalised, so we're going to times top and bottom by the denominator, but with the sign switched, like so. Okay, so the first term is going to be 4 root 3. I want to do this times this. This is going to be 2 times 3, which is 6. Yep, that's right. And then we're going to get minus 2. And we're going to get minus root 3. Okay, and on the bottom we'll get 2 times 2 is 4. We'll get 2 root 3. We'll get minus 2 root 3. And then finally we'll get minus 3. Lovely. Okay, let's collect the terms at the top. There's 4 root 3's minus a 1 root 3 is 3 root 3. And there's 6 minus 2 is 4. And on the bottom, these two are going to cancel out. And we've got 4 minus 3 is 1. So it's just 1. Perfect. So that is exactly what they've asked us to show. So that is a nice 4 marks, particularly for a question 24. Lovely. Okay, question 16. It says, without a calculator, not used a calculator so far, so why would you expect I would? Show you're working clearly. Okay, so we've got this. So yeah, first thing I'm going to do is rationalise this. So I'm going to multiply this top and bottom by root 2 plus 1. Root 2 plus 1. And then afterwards, we're going to do root 2 to the power of 5, which looks like this. This makes 2, this makes 2, and then we've also got this root 2 on the end. So this is in fact 4 root 2, like that. Again, I might just leave that work in there because they've just asked for extra working, so why not? So minusing 4 root 2. Okay, great. So let's do the rationalising part first. So we've got 12 times root 2 and 12 times 1. So that's 12 root 2 plus 12. And on the bottom, we will have root 2 times root 2 times 1 is root 2 times root 2 is 2. Root 2 times 1 is just root 2. And then we've got minus 1 times root 2 is minus root 2, and we've got minus 1 times 1 is minus 1. Perfect. So this is 12 root 2. Oh, and I've also got to take away the 4 root 2, don't forget that. Okay, so we've got 12 root 2 plus 12 over, what is, those two cancel in the middle, 2 minus 1 is just 1. Perfect. So this is essentially 12 root 2 plus 12, and then minus the 4 root 2. So we've got 12 root 2, take away 4 root 2, is 8 root 2. It's 8 root 2 plus 12. Oh, that's not what they've asked us for. Okay, don't fear. This must convert into this. We just have to show that. So, let's write this out as, well, what is 8? 8 is the square root of 64. So it's the square root of 64 times the square root of 2 plus 12. Now what we want is we want a square root of 32, don't we? That's what we want. We want a square root of 32. So if I want a square root of 32, I can say that the square root of 64 is the square root of 32 times the square root of 2. And then there's also another square root of 2 there as well. Perfect, so that works. And now the square root of 2 times the square root of 2 is 2. So this becomes 2 lots of the square root of 32 plus 12. So we've shown there nice and clearly that those two are equivalent, and we'll get ourselves the marks. Lovely. Okay, we've made it. The final question. This is such a long video, but hopefully this has helped you nail this topic. I always like to convert them first off, as you might have seen from the other questions. So root 8 is root 4 times root 2, and root 4 is 2. So we get the nice simplified version there. So it's 3 plus 2 root 2. And when we try and find those simplified versions, we're always looking to find a square number. Okay, so we can also do this little bracket here on the side of our page, and let's multiply this out, this square bracket. So we get root 2 times root 2 is 2. That's minus root 2. That's also minus root 2. And this is minus 1 times minus 1 is plus 1. So 2 plus 1 is 3, and minus root 2 is minus 2 root 2. So we get 3 minus 2 root 2 on the bottom. Okay, so right, that's the top and that's the bottom. We need to rationalise them. So we're going to multiply by, yep, you guessed it, the same thing but with the sign changed, or the same denominator. We're going to multiply by the denominator, top and bottom, but with the sign changed. Okay. Right, so how are we going to do this then? Let's just start off with the top. So that's going to be 9. That's going to be 6 root 2. That's going to be another 6 root 2. And this is going to be 2 times 2 is 4. Root 2 times root 2 is 2. 4 times 2 is 8. So plus 8. Okay, lovely. That's the top done. Now let's do the bottom. Okay, so 3 times 3 is 9. This is plus 6 root 2. And then this is minus 6 root 2. And then this is minus 8. Because, again, the same way that we've just done the last one was positive 8. This is just going to be negative 8. Okay, let's simplify now. So on the top line we have 17, and then the surds part there are 12 root 2's. And on the bottom we have 8 minus 9 is 1. Sorry, 9 minus 8 is 1. And the surds will cancel out because one's positive, one's negative. Okay, so we're nearly there. We've got 17 plus 12 root 2. But, once again, we've got to be careful. It's asked us to write it in p plus root q, where q is an integer, and it's just root q. So we need to convert this surd. We need to unsimplify it. So the square root 12 is the same as the square root of 144. So this is 17 plus the square root of 288. And that is a wrap. I hope you enjoyed that. I'll see you in the next one. Bye for now.